Hello, discrete math fans. So we all learned decimal notation a long time ago. So a number like 5,623, that means we have to multiply each digit by its place value. It has a 5 in the thousands place, a 6 in the hundreds place, a 2 in the tens place, and a 3 in the ones place. Take you back to elementary school? Therefore, when we write 5,623, we mean 5 times 1,000, 6 times 100, 2 times 10, and 3 times 1. Add it all up. We can also use exponential notation. We could write 5,623 equals 5 times 10 cubed, plus 6 times 10 squared, plus 2 times 10 to the first, plus 3 times 10 to the 0. And more generally, decimal notation is based on the fact that any positive integer can be written uniquely as a sum of products of the form d times 10 to the n. Each n is a non-negative integer, and each d is one of the decimal digits, 0 through 9. We're going to talk about binary representation of numbers because there's absolutely nothing special about 10. Now, the only reason we use 10 as a base for our usual number system is because we have 10 fingers. An alien species that has 3 fingers on each hand, they might use base 6. So later on, we're going to show that any integer can be represented uniquely as a sum of products of the form d times 2 to the n, where each n is an integer and each d is either 0 or 1. That is to say that d is a bit. A bit is the smallest amount of information that's possible, representing either 0 or 1. For example, we could take the number 45 and write it as a sum of powers of 2. So 45 is equal to 32 plus 8 plus 4 plus 1. And you should observe that everything here is a power of 2. So then 32 plus 8 plus 4 plus 1 can be rewritten this way as 1 times 2 to the 5th plus 0 times 2 to the 4th plus 1 times 2 cubed plus 1 times 2 squared plus 0 times 2 to the 1st plus 1 times 2 to the 0. So in binary notation, just like decimal notation, we're just going to write the bits and not the powers on the base. So here's how we're going to write it. 45 in base 10 is the same thing as 101101 in base 2. So this expression here is called binary. This expression on the left is called decimal. Okay, that's all for now.